Okay, I'm going to pick this up where I was before, which was at this location. However, I'm going to attack this with method of sections. So let me go back to the original drawing, which was up here. Let's see, I got down to here. So let's take this part of the drawing. I am going to try my best to copy all of that. Copy. And then I'm going to try to run to the bottom, say right there, and drop it. Zoom in. Move it up. Try to align it with the grid. Okay, I think I've got it here. If you zoom in on it, you can see the points aligning it with the grid. And since this is to scale, I can use these distances straight up. So what method of sections does is this. This is the drawing as I sit here with the loads on it. I actually can just do this. And just say those are the loads. So I'm sitting with an object which has these loads on it. Methods of sections are kind of interesting. Let me review which members I do and don't know. So I'm going to verify these by doing a section which is basically right through here. And what I'm going to do is kind of interesting. Essentially, what that means is I can cut this section and take it with me. So I'm going to attempt to do that, but I'm going to attempt to carry the entire member. Do a copy. Oh, oops. Okay. That was not a copy. That was a, oh no. Okay, so here's the copy. I'm going to move over to the right, put myself right there, and do a paste. Then I'm going to attempt to put myself where the periods or the points are aligned with the grid. So in other words, there is a, oops, do that. Okay, I'm trying to get, okay, so there was a point right there as well. So what I'm going to do is I'm going to realize, make some assumptions here, that I have a force pulling in this direction. I have a force pulling in this direction. I'm going to say I have a force, just randomly say it's going to be pushing in this direction, and it's going to be pulling in this direction. Now, this is the major key when, okay, let me make sure, I'm going to go ahead and copy my points. These are C and B. This is point C, this is point B. Normally, they don't draw anything to the left here. This is all erased. I'm drawing it because it's hard for me to clip that with this ink pen. But here's the key, and this is the absolute key. I'm going to write the word key let you know that this is how this works very simply and why this method of sections is so great. If you look at this point, that load and this load produce no moment about that C because the line of action goes right through there. So this means if I summed moments, I'm saying moments, but then I write forces, sum the moments about point C, I'll say that's positive, equals 0. Let me label these. Now, I'm going to try to remember that it's been a couple days, so I don't remember my notation I was using. I'm going to look back, and it looks like I was using F. So this would be F, C, E, F, C, D, and the force BD. So the ones that don't produce a moment, that doesn't produce a moment because it goes right through C. This one doesn't produce a moment because it goes right through C. The ones that do produce a moment, this one, and that one. Because the line of action doesn't pass through C. So all I have to deal with is this. Okay. I'm going to start with these two over here. I'm going to say, okay, the 706 goes this way around C. So that would be a minus 706 times, and this is to scale, so this is 0, 1, 2, 3, 4, and 5. Okay, this 375 goes this way, which is positive. I'm going to list them down. 375. It's moment arms, so if you look at where this is the line of action right there, it's only one down from here. So it's 1. So the only other one I have left is this one. Well, I actually have two components. I have a component that runs this way. Here we go. Let's go back and make this sort of a pencil. So I've got a component which goes this way, and I have a component which goes this way. Turns out the length of this piece, I think I did it before, I'm going to do it again. It's 1, 2, 3, and 4 over 4 squared, and it's only 1 up, plus 1 squared. 16, that's a square root of 17. So what I'm going to do, I'm going to copy this away from here and work on it. So I'm going to do a copy, not a cut. I'm going to go right down here. I'm going to put it right here. So this is like by itself. I'm just breaking it into components. That's all I'm doing right here. This time what I'm going to do is I'm going to say, you know what, I'll go back and use a green pen. So I'm looking at this component going this direction, a component going that direction. So this one is F, B, D. It's a scaled of 1, 2, 3, 4. So it's 4 over the length from this point to that point, which is square root of 17. That is that one. This one is 1 times F BD over square root of 17. Okay. So now that I have these two magnitudes, I can come back in and say, I take This particular force, its moment arm is 2, and it is going about C in a positive way. So it is plus, here, let me go back to the blue, plus. Now, this component is this one. That would be 4 over square root of 17 times F B D. Moment arm from here to here, 2. Now, this one is going this way about C. That's positive 2. So that's positive, and that's 1 over 17, square root of 17, FBD. Now, its moment arm is 1, 2, 3, and 4. So I'll put the 4 over here. Now, the key is, that's it. You have just treated this whole thing as if it's a rigid body. And so now, you'll have to give me a moment because I do not have octave up. And I'll solve this in a moment. So 706 times 5. Okay, so let me rewrite this a little bit. So I'm going to grab, this is all equal to 0, so this is your equation. So I'm going to move these two to the other side. So it'll be 706 times 5 minus 375 equals to 2 times 4 is 8. 4 times 1 is just 4. Okay, so I'm getting closer to the point where I can write a equals to square root of 17 over 8, 12 times 706 times 5 minus 375. Okay, so I'm going to bounce back and forth. Maybe I'll even do it this way. Don't know if this will work, but here. So what about 12 times 706 times 5 minus 375 ends up with 1084 equal 1084. There may be some change in there, but what I want to see now is I want to see if this matched what I had from before. 1084. Wait, was it 1084 or 1184? I see 1084. So I'm getting a discrepancy here. I got 1184.5. I'm probably not going to address the discrepancy because in the last video you may have seen me make an error here, or maybe I didn't. But there's obviously a difference of 100. Let's see. We're looking at node B. So that's where we got our discrepancy from last time. I can attempt to put that back in, but I'm not I'm going to just release this sheet to you guys. You can access this and look for yourself and see if you can find the discrepancy. It could be that I typed something in MATLAB wrong or Octave. Could be that I've done something wrong here. Let's double check. First we'll double check 706, 1, 2, 3, 4, 5. 375 and 1. So I think these are good. The one thing I need to look at is how it broke the x and y components down. 117, 4 over 17. Let's look back and see if that's what I ended up. I ended up with 1 over 17 and 4 over 17. So this checks out. I think this one checks out. Let's see if that forces that way. It goes to the left. Uh-oh. Oops. Okay, let me make sure I've got this. This may have been my FBC going back to the left. FBC going up. So what I'm trying to check FBC, oops. FBC going back that way. FBC going up. FBD, I have it going this way. So I have a plus going to the right. I have it going down. I have a minus 790 and a minus 790. I don't see anything wrong here with this. So I'm going to let you resolve the error between these two. But what we can do here is we can, let's see, we can check this in a different way. Let's do the slice differently. And here's how we're going to do it. We're going to slice this thing the same way, but we're going to look at the left end here. We're going to check this way. So again, I'm going to do it here. I'm taking the left end, but I'm going to go ahead and include these points. Okay, let me try this again. Uh-oh. I don't think, well, I can draw between it. This time we're going to go about right down in here. Okay. Well, I can probably fix this. Put the points right on the grid spacings. Zoom in on it. And really, what I wanted to keep was this one. I did not. So if I took this slice here and looked at the left end, I can do this in an interesting way here. I might have a force running down this. I'm just guessing directions. And then I'm going to guess that it goes this way. Now, this time, this force and this one are both connected to D. So this time, I'm going to sum the moments about D equaling to 0. However, that doesn't eliminate that one. So I think what I'll do is I'll go back and sum the moments about C again. And this one produce no moments, but this one does. So now we're going to take the moments from the left end, from this force, this one, and this one. So the forces that produce no moment about C, this one, this one, this one, and this one. Forces that do produce a moment about C, this one. Uh-oh, I made a mistake in what I just said. Can I not? Okay, this one produces a moment. This one does not produce a moment about C. Okay, again, the green ones don't produce a moment about C because they go right through C. The yellow ones do produce a moment. This should be fairly simple. And now, this one actually is very nice. I get this one producing a moment this way about C, plus 790, and it's 1, 2, 3, 4 times 4. And then this one has a component. I'm choosing a direction, but it might be the wrong direction. So if I were to break this apart, I'll just draw it over here to the right. It goes over 1, 2, 3, 4. So if I put a point here, or say I put a point here, which is B, I would draw a vector that would be F, B, D, but the component that goes down, oops, why am I not allowed to pick that? Alright, it's not allowing me to pick anything. The part that goes down, the part that goes to the right, this is the magnitude. This one is the 1, 2, 3, 4, or 4 over square root of 17 FBD. This one is 1 over, or just FBD over square root of 17. Now, if I break this into components, let's try to switch pens again. I don't know what's going on. Who knows? Apparently I'm in blue the rest of the time. So I have a component going down and a component going to the right. The part that goes down is going in a positive direction, and its value is FBD over square root of 17, and its moment arm is 1. This part is going this way, or negative FBD. Its magnitude is 4 over square root of 17. So now what do? I can move these to the other side, and I'll get a 4 minus 1, or a 3 over square root of 17 FBD, equaling to 4 times 790. And let's just see what I get here. FBD equals to, watch it be something different. Okay, 4 times 790. Times square root of 17 divided by 3. Oh, and it is very definitely different. So let's look back at what I did not include here. Okay, I sliced it. Okay, let's think about this. Four times 790 positive. 1 FBD square root minus 4 over square root of 17. Let's look back at what I did. I'm going to pause this and look at it. Duh. I can't believe this. Okay. Move this to the right a little bit. Move that one to the right a little bit. And you forgot something just absolutely critical. This one has a moment arm of 1, so it's pretty boring. This one does not. It has a moment arm of 1, 2, and 3. So this thing, so now this is still 1, this is 12, so this becomes 11. Now, geez. Okay, so it's not 3, it's 11. Okay, so now I get 1184.5, which that's what it was in the last one. So let's go back. 1184.5. So I've verified this load right here 3 times, one of which is independently off. So my reaction is that I have messed up this one. So let's try to solve that one. First of all, 4 times 2 plus 8. Okay, so let's take a look at the one at a time, the force, and I'll even use the, okay, so I'm looking at the 760. It's 1, 2, 3, 4, and 5 locations over. I'm sorry, it's a 706. It goes in this direction. So it's negative. Okay, let's look at the 375. 375 going around this way, it's basically 1, distance of 1. Now, we are summing the moments about this point C right there. So let's look at the 4 over square root of 7, and it is 1 and 2, and it's 4 over square root of 7. And then we got this part moving out here. It is 1, 2, 3. Uh-oh. Its moment arm is 3 instead of 4. So we have goofed that, and that is a 3. So that means this is a 3. That means this is a 11. Now, 706, let's try to fix this last one. Let's see. So what we need to do is find the equation that I had. The first one I had, which was that one, and change that to 11. And, well, 1182.6. I'm going to accept that as being the same. Let me pause this. Okay, I'm back, and so we're getting 1185 out of one, 1182 out of the other. So I'm sorry, 1182 versus 1184. The key is the method of sections, like he talked about. You just take a truss and slice it. You have to find the reaction loads first, and then you go on from there. So I'll go ahead and end this because I think I took too much time here. I'm at 32 minutes, so I'm going to stop recording and post this one.